Hello. Uh, Good morning and welcome to Tech Days once again. My name is Vjekoslav Babic, and today I'm going to present to you a little bit about how to use .NET Interoperability in Microsoft Dynamics NAV in some practical real-life scenarios. I'd like to start by asking who is here first time on Tech Days? Okay, quite a lot of you. Good. And may I see other hands in the air, like how many of you are still not using .NET Interop regularly? Regularly, like, you know, if you develop every day and then like you don't kind of declare a .NET variable every day, that I would call irregular. So who does a .NET per day? Okay, a few of you. I'll put my hand down. So, in the last couple of years, I've presented here at Tech Days various things about .NET, and my sessions were always called Black Belt. So there was .NET Interop Black Belt and some like web services plus .NET Interop Black Belt. Last year, Luke asked me, okay, can you do, it's okay you have this Black Belt thing, but can you do the beginners thing? So last year I did .NET for beginners and .NET Black Belt thing. And then Luke said, can you do something like in between, like for mere mortals, he said. So I said, well, okay, I'll do something like that. So who is mere mortal? Okay, there are more people declaring .NET every day than being mere mortal. But so here's this mere mortals presentation. This is why it's called for mere mortals. I've introduced myself a little bit. So apart from me being Vjekoslav Babic, I'm also an MVP. I'm blogging on Vjeko.com. Please visit the blog. Most of the stuff that I'm going to talk about today has not been presented there yet, but everything that I talk about today, including all of the examples, are going to be posted there today. Soon after the presentation, before 8 o'clock in the evening, certainly. What are we going to do today? So this is not going to be a theoretical session. You can download any of the previous sessions from Mibuso. I intentionally do not want to start explaining how to use .NET. So this is not going to be like step-by-step thing from the beginning, like how to declare a variable, where to look for variables, etc., etc. Instead of that, what I want to do is essentially arm you with some additional tips and tricks and tools that you can put under your belt and actually use in your daily life. It's difficult for me to tell like these things are useful from .NET, these things are not, because you know in real life there are various scenarios that you will encounter and various needs that you will have to meet. So I have picked some examples which are explanatory enough so that you actually can understand how .NET Interoperability operates. And I've also taken some examples which are cool enough so that you can see, wow, I can do these things now, which you probably couldn't do before. So here we are going to cover a little bit about arrays. I will quickly explain why. Then about strings, then about regular expressions, file system. File system is important. Surviving different data formats, which I believe is kind of relevant for us, the ERP people. Then how to convert between types, a little bit of that. Also how to handle base 64. This is probably both useful and useless example because many people do not know what base 64 is, but I will explain. And for all of you who do, you will see how easy it is in .NET. And finally, at this point, I will stop doing stuff primarily or actually exclusively in CL. Up to this point, everything will be just C-side and CL. Then I will move to Visual Studio and I will tell you how to use it like a pro. So how to properly do certain things in C#. So if you're not a C# developer, you can still do things right without having to think, did I do it right? Is there a better way? So this is going to be the content. I'll start with arrays. And this is obviously not an ancient Chinese proverb, but my position is that even though I've heard that .NET arrays are complicated, they are unnecessary, my position is that a CL developer needs to understand .NET arrays. So why do we need .NET arrays. I mean, we do have arrays in CAL. So the reason why we need .NET arrays is because they are all over the place. So if you take a look at the symbol menu, a lot of .NET methods just take arrays as parameters, or they return arrays as return values. And if you are not able to use them, then it means that a large part of .NET is just out of your reach. So you need to be able to know how to work with .NET arrays. When creating a .NET array in CAL, which we will see pretty shortly, you have a very simple pattern. So you declare a variable of a type array, and then the syntax is this. Essentially, you have to call this create instance method. Do not forget to assign it to a variable of type .NET array. And then two parameters it accepts. First is the type of the data that you have to create. There is this get.NET type function in CAL, which helps you with that. And the second is how many elements you need. So it's different than in CAL. In CAL, you just set dimensions property, and there you have your array. In .NET, it's a little bit more complicated. So for example, here, if I want to create an array of date times, then I simply call this create instance, get.NET type. I can pass a constant of the type that I want. So this 0 dt stands for blank date time. Or for example, blank string stands for blank string. So if I want to have an array of strings, I can have get.NET type blank string and then the number of elements. So that's a little bit of arrays. So let me declare an array for you. So I'm going to create a new code unit and then create an array. So a scary thing about .NET is that every time you have to declare a .NET variable, you have to start with .NET, and then you have to press F6 to get the assemblies list, and then once again, and then here you have to choose the correct one, and this can be scary because there are so many of them, and then it requires some scrolling and looking, or which version do I choose, and then I select this one, and then here, okay, where is the array? Okay, it's here. So now I have declared it. My life hack is essentially help yourself. So there is no magic in declaring this variable, so it's just string. So just do something like that, where you have common types, and then when you need to create a type of something, just copy and paste. It will work just fine. So you skip that part of trying to pick the correct assembly, etc. So that's just a little hint. I'm going to abuse it today a lot. Oops, this is a slide from last year. Yeah, I will repeat some stuff. So this is going to be probably the only thing I will repeat from the last year. So system.string. Is there anybody here who never ever in your projects had to handle text? So many of you. Okay. I expected so. So we have text data type in CL. We can use it to store textual information, obviously. With NAV all up to the version 2013, we were limited to 1,024 characters per variable. In .NET, we can have up to 2 gigabytes of data within a text variable. But this is not the most powerful thing about system.string, which is essentially the same thing as text. System.string is a class in .NET which allows you to call many different functions which are not available in CAL. So in CAL, text is not a class. It's essentially just a value type. It's a variable which can hold a value. And if you want to do something with text, such as, for example, take a substring, you have to call another function. In .NET, nice thing is that everything that you have is an object, essentially. Even though it's not really, it may be a value type, but still it behaves like an object. String is one of those things. So string allows you to directly call into the functionality of string, like taking a substring, turning it to uppercase, or turning it to lowercase, or doing some funny stuff which CL simply cannot do. So I'm immediately going to show a demo which will demonstrate both power of the string variable and also how to use arrays. So I will start with parsing a delimited string. So let me start with this array. I'll call it array of delimiters. And I will declare a variable of type string. So .NET, and again, I'm just going to use this string from here. So quick. You don't have to instantiate a string. It doesn't require a constructor, pretty much like in C#. So here I will start with hello everybody and welcome to Tech Days 2014. Enjoy your time. Okay. So this is my string. Imagine that you need to parse it into words. Has anybody ever had to do something like that? Okay, now many more. How do you do that in CAL? Yeah, you spend a lot of time, like in between 15 minutes and an hour, depending on your proficiency and everything, but you will have to write some code to do that. So let's start with taking a look at what string can do for us. So there is a function called split, and this split returns an array, and it also accepts as arguments, just a second, this array of strings or array of characters, which are separators. So I can actually not look for one single separator. I can actually look for many different separators and then split the string into words which come out of whichever value I have. So I will start with declaring another variable. It will be character, and then I will instantiate this array first. So I will say array of delimiters is create instance, get .NET type of character, this is my variable, and I need to have comma, space, exclamation mark, and dot. So I will have 4 elements in my array. So here I will say character is, first let me start with space, and I will put a value, array of delimiters, set value, character at position 0. Arrays are 0 based in .NET. Then I will just copy this 3 more times, 1, 2, 3. I'll have dot, I'll have comma, and I'll have the exclamation mark. I'll put them on different indexes. And here I have my array of delimiters. I will also declare array of results. So this is another array. Here I don't have to instantiate it. I simply can say array of results is string.split, and then I pass this array of delimiters into it. I'll save this. Yeah, thanks. Okay, good. And the last thing, of course, to show that it really works, so I will declare an indexer. So I'm simply going from 0 to length of the array -1. And then, do you see this? Probably not, right? Okay, I'll remember to do that. So what I do, I iterate from 0 to length -1, and then I get the current value, actually the value at the current index. I'll save that. So, and I will run that to see if it actually works. Okay, I have to reconnect the server. Happens occasionally when you close and open the laptop. So, hello, everybody. Okay, spaces are not. And welcome to Tech Days 2014. Okay, so enjoy your time. Okay, so it didn't quite react well to those situations when the two delimiters are together, but I could really see that any of those blank strings, they were not spaces, they were just blank strings. I could then remove them if I wanted to, but my point is here. So this is a simple way how to use a method such as string to actually do something which might involve much more time in pure CL and much more debugging. Also, not to mention reinventing the wheel. Another thing that we could do, for example, is find an extension of a file name. So imagine, has anybody ever had to find an extension of a file name? Okay, good. So how did you do that? You probably looked for the dot and then tried to find the last one, and then everything that remains is the extension. So in CAL, we can essentially, yeah, I've violated my own best practice, so we'll start with the new code unit demo 2. Yeah. So it's keep making those mistakes. So I will start with string and I will copy it again. So here's my string, and I will just say that my .file is strange.dl.zip. So what is the extension here? Zip, yeah. So how do I get to this zip? It should be easy. If I take a look at string, let me make it smaller. I have this function called last index of. So it will tell me what is the last index of a specific character that I'm looking for. So if I actually show here, it expects a character, so I can say I'm looking for this specific character. I'm looking for the last index of that one. So here I will say that message extension of this file name is, and then string dot substring, okay, and then string dot last index of, and then dot. I'm missing one more, and let me run that. Sorry? I didn't understand. Behind the message, what is behind the message? Yeah, but I have put it there. So this is the code, and this is the result. So it tells me the extension is .zip. Now, this is not to say that this is the correct way to get extensions from file names. I'm going to give a better one. This is just to give you an idea of how to use this system.string. It is like manipulating strings and text data is a very frequent task that we have to do in our regular lives as developers. And it is easy to reinvent wheels all over, and all of them are already invented and working pretty well in .NET. So this is a couple of smaller examples which are not that important, but good to just give you an idea of what .NET is and what it can do for you. The next thing is regular expressions. So I want to talk a little bit about them. So regular expressions, they look ugly. They don't look quite as regular as the name suggests. But what they do is they allow you to analyze the content of text. Has anybody used or done something with regular expressions? Okay, good. So typical things where we use regular expressions is to verify that the user has entered the correct stuff, like the phone number matches the schema, or that email address is valid, or that, I don't know, you can search, for example, you have a large amount of text, you can select all of the email addresses from there. You can replace things in there. So these are typical tasks to do with regular expressions. So again, if you do that in CAL, without .NET, without any regular expressions or similar, it's going to be a tedious task. It will just waste a lot of your time. So let's do this simple detection of email addresses. Let me verify if all of my customers actually have correct email addresses. So I'll start with creating a new demo. So I'll start with regex class. It's .NET, and I'm going to copy this. So at this stage, let me just shortly explain constructors. Constructors are methods which create instances of classes. So in .NET, we need to construct or instantiate every single class that we want to use, unless they are static. So if you have a constructor, you usually need to call it first. So here I will construct my instance of regex class. So it accepts one parameter, which is string, which is the regular expression that I'm using. So here I'm going to use the regular expression for valid email. I've prepared it earlier. So this is what it looks like. Oops. Okay. Don't try to read that. It's utterly unreadable. And let me start with rec customer. So if they are customers, I'm repeating until there are no more customers. And here I want to check if customer's email address is valid. Let's take a look at this regex and the method that it provides. So here we have this isMatch method. This isMatch method returns a Boolean, it accepts a string, and it tells us, does this string matches the expression that I'm looking for? So I'm going to use that. So if not, regex.isMatch, and then cus.email, then message, this does not appear to be a valid address, cus.email. Good. So if I run that, so this does not appear to be a valid email address. Okay, and a blank one. Okay, I'm going to get a bunch of those blank ones. I didn't skip those, but I could. So this is an easy way to detect, for example, email addresses. Another thing where you can use regular expressions is finding and replacing. So for example, imagine that you have a piece of text such as this. So I'm going to declare a text variable, which is again. So here I have a couple of email addresses. I want to replace them with something. I want to hide them. For example, this is a web page. I just don't want my email address to appear there for spam avoiding reasons. So I will start again with instantiating a regex. I will use a different pattern because this pattern matches the whole content of what I've provided. What I want to do is actually use the inside of text pattern. So actually I can do it myself. It has \p and \p at the beginning and at the end. And here what I can do is message and just show the result of regex.replace method. So again, there are a lot of overloaded variants of this replace method. What I'm going to do is use this one, which is a simple one. It accepts a string that I want to replace. inside of, and here what I want to replace any match with. So here I will just say email hidden. So once again, I'm zooming in. So this text contains 2 email addresses. I'm hiding them. Okay, I'm missing something again. I'm not good at parentheses, obviously. So, okay. Running that, and it will show this. So both instances of this email address were hidden from the text. It could find any, so it didn't find this specific one, it has just found any email address and then replaced it with something else. So this is regular expressions. Again, useful namespace with a lot of useful classes in .NET. Another area where I want to go today is handling files. So we often handle files. So we save files, export stuff into them, we read files, read data from them, and CL as a language is fairly limited. I mean, yes, we can create files. Yes, we can open files. Yes, we can create temporary files in temporary folders. But for example, can we create a folder or a directory with pure CL? Not. We can. No, we cannot. Or can we actually do many of, like, let me not theorize too much. Let me just go into a demo and show a couple of things that you can do. What I'm going to use here is a couple of classes. I will start with file and file info. File class allows you to access files without context. So it means if you have a quick operation to do on a file, you use the system.io.file class. For example, you want to just append a line of text into a file. You do not need to declare, actually open a file, then write into the file, then close the file in 3 operations. You just call one operation and it does everything. So this is, for example, system.io.file. And then you have system.io.fileinfo, which provides you some contextual access. So if you want to repeatedly write to the same file, then you can use file info. Very similar with directory and directory info. So you can create directories just as a single command, so like just do this, and then it doesn't remember any context. And then you have system.path, which allows you to construct paths, analyze validity of paths, and similar. So let's see a couple of demos. Typical things that we often might want to do is like creating a directory structure, then appending text to a file, and then checking if a file name contains valid characters. So without regular expressions. So I will start with a new demo. So I start with creating a directory structure. So I will declare variable of type directory, .NET. I don't think I have actually exported it here in my cheat sheet. Oh, I have. So I'm declaring system.io directory. And let's take a look. So it has this method called create directory. And it accepts a path that I want to create. Please see that there are no constructors in there. So what does that mean? If there is no constructor on a class, it means the class is static, which means you don't have to instantiate it. You can just start calling its methods. So here I will do just that. I will go and call this create directory. And then let's see, what do I have in my disk? Just let me take this thing away. So here I have this temp folder, which is blank. So imagine that I want to create C, temp, and then subdirectory, and one more, final one, I promise, and then leave it at there. So you don't even have to recurse yourself, as you would have to do in, for example, shell in older days. So I run that, and let's take a look. Did it comply? So I have subdirectory, one more, final one, I promise. Simple. And now let's append some text to a file. So here I will declare variable of type file .NET. I will just quickly change directory into file. And let's take a look at what file can do for us. So it has append all lines, for example, and append all text. So depending on what exactly we want to do, we may use one or another. So I will start with this append all text. So I will say file.append all text and then specify the file. Let me take a file from this directory. And then call it techdays.txt. And what I'm appending here is hello world. Oh yeah, it should not be called file. Let me call it .net file. It's not that I like Hungarian notation, but it makes it simpler. So let me run this. I run this piece of code, and the file appears. You see, create directory didn't fail for me, because the directory is already there. Why should it fail? Because the purpose of this command is just to make sure that directory is there with the full path that you specify. And here I have this TechDays hello world. And if I call it again, it will append the text here. So another hello world. I could, if I wanted to, I could insert line breaks. It's up to you whether to insert or not. So that's how easy it is to handle files. And finally, the last one, how to check if a file name contains valid characters. This is also something that you frequently have to do. Like in any setup page where users have to enter file names, you have to check if the file name is actually correct. So let's do that as well. So here I will declare one more, which is called path.net, and it's of system.io.path type. So it has this method called, just a second, to minimize, not close. So it has this get invalid file name characters. So this path does not check if the file is valid, but it tells me which file characters are invalid. Okay? So obviously I will need an array here. So let me do that. I will declare an array. So array.net. Let me take the array from here. Array of invalid cars. So I will say array of invalid cars is path dot, actually, let me just do it like this and get rid of one path. Get invalid file name cars. And then I will use the string type to actually verify if any string, like for example, here I will have file name, which will be text, and I will have string, which will be .net of type system.string. So file name is this a valid file name .txt, and then message is valid. So here I will print the file name, and then let me check how do I verify if this file name contains an invalid character. I just go and call string index of any. So this index of any tells me the first index of any of given array of characters. So I'm looking for index of any and then array of invalid cars. Okay. Save that. Sorry. Larger than 0. So I will run that. And it tells me, oops. Sorry, let me see. Yeah, I didn't specify what string is. String is file name. Yep. So I will run that, and it tells me that, is this a valid file name? It says yes. Didn't expect that. Yeah, I will put this / equal and colon. Yeah. Sorry, that's true. Thanks. So I'll run that, and it says this is not a valid file name. Let's see if it can actually detect a valid file name. Is this a valid file name? And I run that. No. I'm obviously missing something obvious. I will fix this, and when I upload it to my blog, it will be correct. So yeah, so it should be like this if it, yeah, exactly. This should be, let me see, run that. This is valid, yeah. And here I put a / and a colon, and no, yeah, okay. That's true. I keep thinking in CL terms where 0 is, strings are 1 based, in .NET they are 0 based. Okay, I intentionally did not prepare any demos. I wanted to do everything here so that you can see how easy it is to write .NET. I didn't want to appear with like 100 of examples and then just show them like this is how to do this or that. And obviously, yeah, I make mistakes. Anyway, let's move on. Let's move to another typical thing that we might need to do as CL developers, and especially as ERP people. Have you ever had to handle dates or numbers in different formats and not being sure like which format that was? Like importing text files, and then like you are importing opening balances for a new customer, and then suddenly some numbers seem to be multiplied by millions, some by 10,000, some by hundreds. So it all depends where dots are, if there are any spaces inside, what are spaces, etc., etc., etc. So CL isn't particularly good at handling date, time, and number information in different cultures, as we call them in .NET. So when you run CL code, it understands your own local culture, which is your local regional settings in Windows, and it can interpret numbers in that culture. If you want, like for example, your decimal separator is comma, and you get a text file which has decimal separator as dot, you will not be able to interpret it correctly. So depending on what dot means in your regional settings, it might work by multiplying numbers, not really randomly, but it appears random, or it might fail altogether. So you would either have to ask the customer to supply the files with a different format, or you could just ask them, okay, what is this format that you're supplying in? And if they tell you in .NET, you can easily fix that, because in .NET you do not have this problem. In .NET, as long as you know which culture the format belongs to, you can interpret numbers and dates. So let's just do a quick demo. What I'm going to do is I'm going to show how to read formatting of numbers and dates in different cultures. So here I've cheated a little bit. I've prepared a page. So this page has 3 fields. The first is called culture, the second is called text, the third is called result. Result is non-editable, and then I have just put actually 3 lines of code in the validate trigger on the culture field. So here I'm essentially creating a culture from user's input, and then I'm clearing the result and text. Everything else is I'm going to code now. So what I want to do is essentially when the user, let me run the page. So when I run the page, this is what I get. 3 fields. My idea is when the user enters the culture name like EN, US, and then enters some text, that here in the result we see that text in the correct actually interpreted correctly as date or number. Okay? So to do that, I will declare, actually I do have certain variables declared. I have date time and I have decimal. Actually, I don't need those. I was experimenting some. So here, this date time and decimal, they are .NET date time and .NET decimal. Apart from being able to hold a number, they have a very interesting function called parse. So if I take a look at decimal and then parse, it can accept a string, it means a piece of text, and it can translate it into a valid date time or a valid decimal. And it works similar as the evaluate function does in CL. However, it can accept an additional parameter, which is the culture, actually it's iFormat provider interface, which is what every culture info class has on itself. So essentially, if you create a culture info based on the identifier and you pass it into this parse method call, it can translate essentially any valid date or number format in that culture into normal date time variable or decimal variable in CL. So let's do that. Here I will start with dates and times. So here I will say result equals, and then date time, so I can type it, date time dot parse, and then this text, and I'm passing this culture info into this method. So I'll save. Again, I need to format that, of course, because I have this result, which is text. So I will run that, and here I will start with a simple, like enus. And here I will parse the following text. So it parses this as 1st of January of 2014. This is simple, this is obvious. Let's start with some funny strings. Like, for example, I will take this. You will see immediately what it is if you cannot. So I'm using ELGR. I think that's the correct one. Let me see. Yeah. So ELGR stands for Greek in Greece, Greek language, Greece. I'm pasting this Greek text, and it tells me what this is. So it can actually really understand any kind of format which is a valid Greek format in this specific case. Or I can start with, I can take a Russian. So I can take this, and then I can say Russian, Russia, and then paste this, and it gets interpreted as a correct date time. Also, if I do that with numbers, it's essentially the same thing, so it's only more common that you will have to interpret those. So I will start with the result equals format decimal.parse, and then text culture info. So I'll run that, and let's start with RMCH, it stands for Romansh Switzerland, and then this number format. So it's an uncommon number format. Essentially, it reads that. I can take an even more uncommon number format, such as, for example, okay, this is fairly common, actually. So it's Norwegian. I'm skipping Norwegian, but I'm taking this Farsi Iranian, which uses slash as decimal separator. So is it FAR? Yeah. And I'm pasting this number, and it correctly interprets it as the number. So essentially, those built-in functions in .NET obviously can help you with a lot of typical tasks that you have as a developer. Needless to say, you can use the same way like formatting. You can call toString method and then show the date in a specific culture or a specific language easily. So if you want to, for example, if you're selling internationally, you can, and you need to send an invoice, let's say, to Iran, and you need to use this Iranian number format, then you can actually have your numbers formatted correctly. It's not just that you can have a language installed for them so that it can be printed in that language, you can also now format the numbers and dates in that language so that it's fully understood by that culture. Let's move to the next topic. It's streams. Who uses streams regularly, like daily? Okay, but they're not as common as text and as other things, but occasionally all of us need to do something with streams. Streams allow us, actually streams are very simple because they allow us to handle binary data regardless of the storage medium. So in CAL, or in NAV natively, we can handle storage mediums of blob files, blob fields, or storage mediums of files. And .NET has more. It can even have a stream which is unrelated to storage medium. Also in CAL, what we have is two kinds of streams, input stream and output stream, whereas .NET doesn't make that difference at all. .NET actually says, I don't care if you input or write. You can have a random access stream that you can write and read. Essentially, you can read and then manipulate the data in that stream and then pass it on for further processing. So this is how .NET approaches streams. And also, it has different types of streams, not just based on like file stream for handling files. It has, for example, compressed streams that can compress data, etc. So there are many different kinds of streams in .NET. Nice thing with streams is that they fully map to CAL streams. So it means that just the same way I use my string variable interchangeably with text, and I was assigning text constants to string variables, you can do the same with streams. So in any place where you could use in-stream or out-stream variable in CAL, you can now use this memory stream from, any stream from .NET. I'm mentioning memory stream because it's easiest to use, and I will do some demo here. For example, I'm going to download a picture from the internet, and I'm going to store it in a blob field. So let me try to download NAV TechDays. Actually, so this is a good one. So I'll take this. Let me write some code. So first, how do I read a picture from internet? I don't need a stream for that, obviously. What I need is I need a class which can download data from internet. There is a class in .NET which is called web client. So I'm actually calling to declare this web client class. So web client.net and then system.net.webclient. I will start with instantiating this web client, so I call its constructor. The next thing would be to download, to actually download this image that I've found on the internet. To download an image, I need to pass the URL. It's not just a plain string. URL is a class. So I'll take this URL class, and here actually it's URI class. It's system.uri. So its URI is, I'm constructing one again. I'm calling its constructors. I'm constructing it from string, and here I will pass the address of the image that I've just found on internet. So it's this one. I'm pasting it here. And then the next thing is to download this image. Let's take a look, how do we download? So I'm zooming into this web client class. It has download data. This download data, it returns a byte array. Byte array is one of the most common types of arrays in .NET when handling any kind of data. You'll just need to use it a lot. And a nice thing with byte arrays is that it can be easily turned into a stream. So you have an array of bytes, which is essentially binary data that you have downloaded. You can just convert that directly into a stream. So let's take a look how to do that. Next step, what I need to do is a stream to store this binary information in. So I will declare a memory stream. So it's memstream.net. I think I don't have this one. Oh, I do. So this is my memory stream. It's system.io.memorystream type. So I will just say memstream is, I should now call the memory stream constructor. And I will pass this byte array. When I was detecting invalid file characters, I have created a variable of type array of invalid characters. In .NET, you don't have to do that, actually. I could have skipped it there. I'm skipping it here intentionally. So I don't have to declare a variable. I can directly call the method web client download data. So it downloads the data and returns it as binary stream, as an array of bytes. So here I'm just passing this URL. And essentially here I have a memory stream which contains this image which was downloaded from the internet. The only thing I need to do now is essentially to store it in the database. Let me use, for example, item 1600. So I'll declare item, very good, item. So I'll do item get. I'm getting this item, and then I have item.picture.create out stream. I need an output stream to write into, which means I need a stream variable. So we'll declare an out stream variable. So again, let me zoom in. It will be simpler. So here I have created an out stream. So I have a stream that will allow me to write into my blob, and I have my memory stream. So what I can do, there are two things I can do. First thing is simply copy stream, and then say that I'm copying into out stream from my mem stream. So this will compile, okay? Other thing will compile too. So I can do mem stream dot copy to and then out stream. Both will work, okay? And then of course I need to do item.modify. So if I go to my item now and take a look at its picture, it should be blank. So picture is blank. Then I run this small piece of code. Nothing seems to happen, but when I click this, there is NAV TechDays. So this is also a very simple example of how you can use streams in .NET, how you can use streams in scenarios which are kind of unfamiliar to us, but somewhat common. So essentially, this binary, a byte array is something that you will get from many different types of data, like for example, from accessing files, you will get byte arrays. You can get byte arrays by using encoding. For example, if you're using different encodings, you can switch between encodings, like you have text in Windows, let in one code page that you want to turn into, for example, a UTF-8 code page, you will use byte arrays for that as well. Also, I will use byte arrays in my next example here. So one common thing is to change between data types, something like converting let's say strings to integers or integers to strings, etc., etc. We have evaluate in CL, which allows us to translate text into anything, or not really anything, any simple CL type, like for example string to Boolean, string to date time, string to decimal, etc. In .NET we can convert literally any value, built-in value type into any other built-in value type. So this convert class is really evaluates Big Mama because it can really do anything. Let me just declare this variable. So I will start with demo 7 and so, yeah, of course, demo 7. So here I will declare convert .NET. I don't have that one, so I will just declare it the regular way. So I'm going to mscorelib, and here I'm looking for system.convert. There it is. So if I take a look at what convert can do for me, essentially, let me zoom. So I can convert to Boolean, and then it has all of those overloads, like from decimal to Boolean, from datetime to Boolean, etc., etc. And then it has that for all built-in simple data types. Like common thing is like converting, for example, from integers to Booleans. It's something that, for example, C-based languages do natively. CAL fails at, so you cannot convert. Like they are just incompatible. You can use this, for example, like 0 would be false, non-zero would be true. So this is an example of this convert class. Why I find this class really interesting is not those convert methods, which are occasionally useful. Why I really like it is because of these methods. It has from base 64 string and to base 64 string. Let me see, who has ever needed to do something with base 64? Okay. Base 64, in essence, is the mechanism which ensures that you can put binary data or convert binary data into text in such a way that it can be transferred easily over internet and unambiguously. So it was one of the reasons why it was invented was, for example, the POP protocol or SMTP protocol for handling emails. When you attach an image to an email, what happens in the background, because this is a text-based protocol, it gets converted to base 64. What it means is that you take binary information, and instead of chopping it into 8 bytes, you chop it into 6 bytes, and then you have 64 possible values. And then essentially, each of those 64 possible values maps to an ASCII character, which means that you get binary data, which is larger in size than the original one, but is textual in such a way that you cannot miss. It doesn't include any funny characters, like any local characters in your local homepage, or any system characters, which could confuse the clients. So this is base 64. You can use it for simple encryption, because regardless of what you encode in base 64, it always does the same algorithm, and it always looks encrypted. Even if you put text, which is text, like plain ASCII, it will still appear encoded. So it's a very useful thing to do, and now we can do it easily with .NET with this base 64. So what I'm going to do here is I'm just going to take this picture that I had downloaded right now, and I will encode it as base 64 and then save to a file. So here I will start with item. Again, I will get this item. I will do item calc fields picture. Just in case I get the wrong one. Okay, so I'm getting this picture. Now I need to get this data out of this array. Out of this blob. Let's take a look at this to base 64 string. If I take a look at this to base 64 string, what it accepts is a byte array. Okay? So again, our old friend. So let's do this. Let's do convert to base 64 string, and then we need to pass a byte array from this picture. How do we do that? Again, we use streams. Here I use inStream. So I will do item picture create inStream. And then inStream. And what I need to do is I essentially need to convert this int stream into byte array. How do I do that? Because if I take a look at the inStream variable, it doesn't have any methods. But I know that memory stream does. So what I can do is I can declare mem stream, which would be a .NET. Let me just quickly hack it here. io.memory stream. So I will just do a simple assignment. Mem stream equals in stream. Okay. And then here I can do mem stream, and then I can call the get buffer method. This get buffer method gets the byte array out of the stream. And here I have this string. I can actually declare another known one, so file.net system.io.file, and I can write file.append all text, and then ctemp image.txt, and then I'm appending this. Let me see, what's the error here? Yeah, right. And file will have the same problem, yeah. So, .NET file, .NET file. If item picture has value. So let's take a look. It should write something into my temp folder. So here, I will run this and wait for, okay, I get an error. So let me just do this then. Don't know why, but I'll stop there. Really, have 26 minutes to go. I will return to this demo when I complete other important ones. Sorry? Didn't I do that? I did. Oh, you mean calc fields versus has value? I've blogged about that a couple of weeks ago. Actually, you should do you should do that in NAV up to version 2009, I think. And then they switched it, which makes more sense. So calc fields takes everything from the database, and if you just want to check, then you do calc field. Has value first. This is not the problem. The problem is somewhere in here. So it's mem stream is stream.memory stream. Thanks, whoever that was. Yeah, I didn't instantiate my stream, but I'm not quite sure if that will. It is. Okay, thank you. Obvious thing. So here is my base64 encoded image. Okay. So this is, again, some useful functions from .NET. And now we stop with CL. We move into Visual Studio. Let me see, who has never done anything in Visual Studio? Okay, a few of you. So that makes my job easier because I don't have to explain far too much. So I assume most of you know how to create assemblies. The reason why we use Visual Studio, even though we could obviously do most of the things from pure CL, and I really mean that, there is a very small portion of .NET which is not really accessible to you from pure CL. the reason why we would still want to go into Visual Studio is when you need to use some of those features which are unavailable, for example, delegates, if you need to use them, the only way is to create your own assemblies and then use them from there. There are other ones. For example, performance. .NET code, when written as C#, executes faster than .NET code which results from you writing CL and then that being converted to C# and compiled. Take a look at the code of any CL converted to C# and you will immediately understand why. For those of you who are beyond the mere mortal level, basically those who did not raise their hand, it's the reflection, because it's all over. Essentially, no single CL line of code that uses .NET really calls those objects and those methods or accesses those properties that you think you are accessing. It actually uses reflection to do everything. And it makes it slower because it always needs to first check, can I do this? It needs to locate the method by name, for example. It needs to construct arrays of parameters. Essentially, it has a lot of overhead. Probably you will not feel it, but this overhead will still be there. It will still slow things down. So if performance is really important, then it might make more sense to simply go into Visual Studio and write your assembly. So let me just create a quick assembly. So I'm going to Visual Studio. I'm creating a new project. So here in the projects list, depending on your language choice, you will select that language, and then you will select Windows, and then class library. Class libraries are compiling into DLL files. In .NET jargon, we call them assemblies. So I will just create a techdays.2014.mere mortals. So this is the name of my assembly. When I compile this, I will get techdays2014.meremortals.dll. So when you create a new class library, you get a C# or VB.NET file, which is called class1. So here you can write your class. So I'm just going to do a simple class here. So I'm not going to explain the object-oriented development in C# or what classes are. I'm going just to assume that you know enough to be able to follow this code. So I'm creating a very simple class. I will start with calling this class person, and then person has public string name, actually first name, then public string last name. These are now my first and last name. Let me add one more, public date, time, birthday. Okay. There is no date in .NET. So when I build this, what I get is a DLL file. So I'm opening this file. So right click, then open folder in File Explorer, and then bin, debug, and here I have my techdays meremortals.dll. Before I can use this from NAV, I need to deploy it first. Deployment is simple, so I need to take this file, so I'm copying that, and then I need to move it into, actually copy it to C, Program Files, then Microsoft Dynamics NAV, then 8.0, then Service, then Add-ins. So I will paste the file here. At this stage, I will create a new, so demo 8. If I go to my globals and declare person of type .NET, if I go to subtype, here in the server tab in 2015, I will see that I have techdays 2014 mere mortals. So I select that, and here I can see, okay, I don't see the class. I didn't expect that. I expected something else. Let me see why not. Is this class not public? It is public. No, definitely not. Definitely not. So I will, let me see. Without the zoom, it's easier for me. It's not there. I will close my development environment, because once you load a DLL and once development environment locks it, you cannot access it anymore. So I will just save this and I will close this. So public class person, it's in here. Build, rebuild solution. Succeeded. I'm going back to my folder. So it has just been compiled. I'm taking it again. And here I have add-ins server. I will paste it here. Actually, I think I have an explanation for this. I will paste it also in the client folder, because that's where the client folder is where the add-ins reside for the development environment. So it seems to be the malfunctioning auto-deployment feature of .NET, NAV 2015. So let me go again into my demo number 8. So here's this person, .NET, and now I'm going to Dynamics NAV. Dynamics NAV is essentially my client folder. So here, yes, I see it here. I assume that it has to do with auto-deployment feature. It doesn't always work. So I've heard that have you heard of auto-deployment of DLLs in 2015? Sometimes it works, sometimes it does not. I've heard that if it starts with Microsoft.Dynamics, then it automatically upgrades, even though the documentation doesn't say so. Here, I assume this was the reason why I didn't see this class. So now I see this class here, and I can start using it. I will immediately notice that even though I have declared those first name, last name, and birthday, I don't see them here. They are not properties. They're actually fields, so I don't see them there. And we'll get to that pretty quickly. So this was just how to create an assembly. Now, some best practices that I'm going to give to you. I'm not going to teach you today how to create or how to develop in C# or how to develop your assemblies. I will assume that you know enough of .NET or C# to just go there and write some code that you need to have execute from within CL. I'm going to talk about deploying assemblies to global assembly cache and the benefits of them, of that approach. I'm going to talk about how to declare properties as opposed to fields, which is what I've just done. Also, I will explain to you how to make classes serializable, what it actually means and why it is necessary. And also, I'm going to just mention interfaces, and then I will invite you to the PRS session just after lunch in the big room, where I will demonstrate how to actually make use of those interfaces. So let's talk about those best practices. First, Global Assembly Cache, or GAC. This is a machine-wide repository of assemblies, and it essentially solves several problems with deployment of DLLs that were commonly called DLL hell in the old days of automation and Win32. So to put an assembly into Global Assembly Cache, you need to sign it with a strong name. So essentially, it has to have a qualified and a unique name that only you can guarantee that you can change or assign. So essentially, once you assign a name to an assembly, a strong name to an assembly, it's only you who can change it or who can guarantee that it is that assembly. So it has a very strong security effect, because nobody can actually tamper with your assemblies. Like, for example, in the old days of Win32, you have a DLL, like automation DLL, which exposes 15 objects. And these 15 objects have each 5 functions. So what you could do is essentially develop your own DLL, which has the same 15 objects with the same functions for each of those objects, and simply put your DLL in place of their DLL. And suddenly your code executes, because the application has no way to know whether it's your code or their code or whichever code executing. It is basically the backdoor for all sorts of viruses, Trojans, etc. In .NET, it's not really possible. It would be very difficult to do a similar thing with assemblies deployed into global assembly cache. So it is always a good practice, even though for global assembly cache, it is a prerequisite to sign the assemblies with a strong name. For regular assemblies, this is not a prerequisite. You can just write an assembly, just as I did, and not deploy it to global assembly cache, not strongly sign it, and then anybody can tamper with it. So it is a good practice to sign them always, even though if you don't intend to put them into global assembly cache. So if you always deploy your assemblies to global assembly cache, it will force you to not forget that you didn't sign it. So that's one of the reasons why deploying into global assembly cache is good. The other one is it simplifies development. So for example, here I have first deployed it to the server folder, then it didn't quite work, then I deployed it in the client folder, and then it worked, but I had to restart the client. Sometimes you might need to restart the service tier. With the global assembly cache, it's simpler. So yes, you will still have to restart the service tier sometimes, development environment almost always, but for most situations, you don't have to copy it into multiple places, and also it's very easy to deploy to global assembly cache. So let me demonstrate how I can put this assembly into global assembly cache and what happens then. So to put something into global assembly cache, you need to run this development environment, and here you have a utility called gakutil. So gakutil actually takes your DLL and stores it into global assembly cache if it's possible. So what I want to do is I want to call this gakutil from my Visual Studio. So here I will take a look at properties, and then I have build events. So I use post-build events to actually deploy my assembly into global assembly cache. So here I have to write gakutil -i, which stands for install, and then I need to put the name of the assembly, which is essentially the DLL. I'm not hard coding it, I'm simply using a macro command, which is target path. I can check those macros here if I click edit post build. Then this target path, it's essentially the DLL full name. So it's the name of the DLL plus path. So when I put it into global assembly cache like that, it essentially just takes this DLL and stores it there. I will also use -f, which means it means force the reinstallation even though the assembly is already in there. I cannot just call that. So before I can call that, I have to do at least one thing. First is I need to reference the path of this gakutil. So the easiest way to reference the path to gakutil is essentially to just take this shortcut. So I'm opening the file location, then right-clicking here, properties, and then taking this target box and just pasting it in here. So I need to clean it up a bit, so I will expand this so that you can see what I'm doing. So we'll zoom in once more, and since this is not a command prompt, I need to take this out, and I just need to put call, and I need to take this last quotation mark out. And then I will click OK. So when I build this solution, okay, I got an error. So it has failed. There are two things I need to do. First is I need to sign. So if I take a look at this output, it will tell me that failure adding assembly to the cache because administrator permissions are needed. So it's not the Preben's problem, it's actually another one. So to do that, you need to run Visual Studio as an administrator. So that's the first thing I will do. So I will close Visual Studio and then run it as admin. Then when it starts, it will fail again because of the other problem. So here, I'm opening my Mere Mortals demo. And I will build the solution. And now it will again fail, and it will tell me that it fails because assembly requires a strong name. So this is, if you remember my slide, essentially, if you do this like that, you will never forget to assign a strong name. It's always a good practice for assemblies to have a strong name. Assigning a strong name is simple. You just, again, go to Project Properties, select the Signing tab, click Sign the Assembly, and then either use an existing file that you use, for example, to sign all of your assemblies, or you create a new file. I'll call it TechDays 2014 Mere Mortals. I will not protect it with a password. And then I will rebuild my assembly, my solution. And it tells me that assembly was successfully added to the cache. If I take a look in my development environment, I will declare person2.net, and then if I take a look at this list, I don't need to go to Dynamics NAV, I need to go to .NET tab. This is the contents of the global assembly cache. And here I will find TechDays 2014 Mere Mortals. So it's there. If I click that, it has this person class. One caveat, these two are not the same class anymore. So they are two different classes. These are two different DLLs, actually. So it's best that you first sign, then use. So I will delete this first one. Okay, so this still didn't expose my first name and last name and birthday, so I need to do something else. So this is the first best practice that I have for you. The second best practice is just declare everything as properties. It's easy because CL understands properties. CL does not understand fields. What are fields? Fields are simply variables declared directly on a class. Whereas properties are not variables. They are, in essence, they are methods. So when you have a property called first name, you will have accessors or access methods if you want. A get access method and a set access method. So when you assign a value to a property, the set method is called. And when you read a value from a property, the get method is called. So properties are essentially methods. This does not explain, though, why NAV doesn't expose them, why you don't see them. That's really strange decision by Microsoft. They probably fixed that because I don't think there is any drawback to that. Yesterday at my session, at my pre-conf session, I've shown how to access fields from CL, though, and the example is on my blog. So if you want to access field, it's possible. It's just a little bit tricky. You need to call some reflection. But let's see how to do it the right way, how to fix it, and how to actually expose those first name, last name, and birthday as properties. The old-schooled way would be this. For each of the properties, you would have to have a private member or a private field. So private string first name, for example. So this would be used to store my first name. And then I would have get access method, and I would say return first name. And I would have a set access method, which would be first name equals value. So this is the old school way to declare properties. And it's also the right way to declare properties if your access methods do something else other than just assigning a value or reading a value. So properties are nice because you can easily take an access method out and make it a read-only property, or you can take get method out and make it a write-only property if you want. So this is how to implement a simple property. However, there is an even simpler way. There are auto-implemented properties. That's a feature of C#, not quite sure which version, 3 or 2. So instead of just writing the access method, you can just say get set. So you're telling which accessors you are exposing. And the compiler does essentially this for you in the background. So when you compile that, this is what you get. So these are just auto-implemented. You don't need to write any code. So essentially, I don't need this. This, I will just say public string first name and then get and set. And also the birthday, I will add get and set. So I will now rebuild my solution. So it is again added to the cache. It doesn't show immediately because my development environment has already loaded an instance from the global assembly cache. It does not check if a new one is deployed and then rereads it, so I need to close it and restart it. Good. Let me go back into here, and here I have my person. And now, if I take a look at properties, I have birthday, first name, and last name. And if you ever wonder, like, why you don't see properties that you expect to add, it's probably because you just declare them as fields. If you want to use something from NAV, if it's public, then just make it a practice. Whenever you declare a variable, just add this get set, and you're good to go. So from C# you have no problems accessing fields. From CL you will, so it's easier if you simply just declare them as properties right away. Okay, now serialization. This is an important process. Serialization is a process which allows you to have one class, then essentially store its current state to be able to restore it later. So you might think, like, why do I need that? Typical example is just going to come right now. So I'm going to immediately start with demo. We are short on time, so I want to show the problem with this. So here I have person, and I will instantiate this person, and then I will assign first name John, last name Doe. So this is running on the server side, okay? Now I will declare a person2, which is going to be .NET, but I will say that it runs on client, okay? It's going to be the same type. So if I do this, which is perfectly legal, and I attempt to run that, my client gives me an error message which says, it failed to serialize. What is happening here? I have service tier on one box, and then I have client on another box. I cannot just assign a variable which lives here to a value, or a reference in this case, which lives there. So before I can do that, because semantically my CAL code should continue executing, it doesn't care which domains these variables exist in. So what it needs to do is it needs to take this instance from the server box and somehow transfer it here so that I have the same context in there as well. So to do that, server needs to serialize that. It means turn it into XML or binary or JSON or something else, ship that content over the network to the client, and then deserialize it, and essentially have a clone of the original one, but allows me to get the same context that the original one had. So how do I fix this error? It's very easy, in fact. So here I will just stop my service tier and stop my client. So I have 1 more minute to go, which is exactly as much time as I need. So I'm restarting this, and I'm going to restart this as well. Back in my C#, I just need to add the attribute called serializable. That's all. So I now rebuild this, go back to development environment, and here I will do message person2.firstName plus space plus person2.lastName, and I run that. Okay, my time is up. Let's wait this client to wake up. So it shows me this, John Doe. Okay. So my point here is routinely just add this serializable. It costs nothing, absolutely nothing. It doesn't make a class slower. It just allows it to be serialized when necessary. When not necessary, it doesn't have any effect whatsoever. Okay, and I have one more topic to cover, which is not that important. That's why I left it for the last, which is interfaces. Interfaces enable like real polymorphism. It enables your class to take any necessary shape of a behavior that you need. For example, this serializable here. By adding the serializable attribute, in fact, I have implemented the iSerializable interface, which allows this class to be serialized. So whoever needs to serialize can observe this class only as the interface. So I'm going to show the real power of that today in the PRS session. So if you want to see that, please join us. That's not the reason to be there. There are many, many more reasons to join that session. But among other things, you would see how interfaces allow you a real flexibility with handling .NET Interop and .NET Objects. So thank you for attending this session. I hope it was useful. Are there any questions? No. Thank you. Yeah, we have a question here. There should be a person. Yeah. So the question was, are there any dependencies when using .NET Interop with other client types, such as web client, tablet client, possibly, etc. in the future? If you're using server-side .NET, which is everything I have done so far until I had declared this person2 variable, no dependencies required. So this works equally well on all client types, because this is happening on the server. However, once you declare client-side yes, then it only runs in the Windows client. So you cannot even make it run in the tablet client or the web client. So you should actually not use client-side .NET Interop. You should avoid it if at all possible. Okay, actually, there is a shirt for you. So I'll just try to throw it strongly there. Okay, good catch. There are more shirts, so please ask questions, otherwise I will have to wear them all. Yep.
We tried to use a bit
Yes.
this .NET, and the
Another
issue
question?
we have was exceptions. Is there any workaround to using exceptions in the vision, except for creating your own DLL?
So the question was about exception handling. Like there is problem in CL how to handle exceptions, because .NET really allows you a lot of exception handling. I will get back to that question just immediately. So in fact, there is a workaround. I've also blogged about that. My, I think, last or one before blog post has a trick how to use exception handling, which is limited to you being able to handle exceptions that happen in .NET. It requires an external DLL, but it covers all of exception handling scenarios then. In essence, in 2015, you get last error object. So if you have if code unit run, and then it fails, you can get last object, which is system.exception, or whichever descending class it is. So it means that you could you could not have try-catch stuff in CL, but at least you could analyze the exception and see what exactly happened. And you can get the context of the exception. But the answer really to your question is no, we don't have any kind of exception handling, any real exception handling in .NET Interop. And if you expect exceptions, then you really need to wrap your stuff in your DLLs and deploy them. There was a question
yes.
somewhere over there.
Yes, here. Usually you do not develop on server, I guess. So when you deploy your DLL to the GAC, do you also have to do this on the server side and with the same GAC util? Or?
Exactly, you have to. So here I was working on a single machine, and on a single machine deploying to GAC solves those scenarios. I don't have to deploy it twice. This is one of added benefits of adding it to GAC when developing. When deploying DLLs in production environments, you do not get any significant benefit from adding them to GAC. But you would have to add them separately on the server and on all of the clients. this auto deployment feature does not work if the assembly is in GAC. So if you put the assembly to GAC, then auto deployment will not work, even though it doesn't obviously seem to work in all other scenarios as advertised, but I'm pretty sure that the next cumulative update will take care of that. Or I hope. Any more questions? Yeah.
Yes, I have one. Is it possible to debug the C# code when we start the program in Dynamics NAV? So
Yes.
that we can hop into
It
C#?
is.
Okay.
Yes, it's possible. Essentially, what you need to do is you need to start Visual Studio as administrator, then you go to debug, attach to process, then you need to make sure that show processes from all users is selected, and then you need to find Microsoft Dynamics server.exe. There's the shirt for you, it will arrive shortly. If you're debugging client side, then you essentially need to attach the debugger to the client, okay? And you can attach to both simultaneously, so, and then you can set breakpoints, and it will just stop when it hits the breakpoint, and you can access your C# code of your .NET DLLs. Yep. Okay.
Do you have any solutions for casting?
For typecasting, actually no. Typecasting works completely
It's still
funny.
not possible.
Here's your shirt. That's an excellent question. So there are a lot of issues with typecasting because C# or .NET allows you to upcast variables. Like you have a descending class which you can assign to an upper class variable. In CL you can downcast, you can crosscast, you can do what I don't even have a term for. Like you can cast completely off the hierarchies. So essentially, CL has tons of problems with that. And essentially you cannot directly cast. You depend on the runtime to resolve those issues or to pinpoint those issues. So there is no way that CL can help you at compile time detect typecasting errors. Exactly. So if there are problems with typecasting, you would have to write an assembly. I mean, normally you would test your program. You would figure out if there is any typecasting issues. Also, what you could do is you could use reflection and system.type class to actually verify if the types are of correct types before assigning variables. However, there is a bug there, which, again, it lives in my to-do list for my blog. Essentially, you cannot call on system.type. There are methods which allow you to check the hierarchies to see if something descends from something else or if something implements an interface. They do not work well. They always return false. So it's funny. But yes, if you really depend on casting heavily, then just wrap it in your C# and deploy it as DLL. I think I have more shirts. These are PRS shirts though, but they are equally as good, I promise you. So blame Luke. He only gave me 5 shirts for
So can we use Visual Basic or C++ as well to create these DLL classes?
Visual Basic, C++, F#.
Whichever is on the .NET.
Yeah,
platform,
Delphi, .NET, whichever language that compiles into valid .NET assembly, you can use it.
And
Yeah.
is there any like Visual Studio version as well? Like we can use 2005, 2008.
Essentially, it doesn't matter which Visual Studio you use. It matters which version of .NET Interop you produce. .NET framework you target. So with NAV 2009, you have to target version 3.5. With 2013 and upwards, you can target 3.5 and up. So it's, there is a shirt for you. Let me just throw it again. Let's see who is better. Me. Okay, sorry. Just one disclaimer about PRS shirts. They come in different sizes. So if size doesn't match, like contact us, the PRS folks, especially Mark Brummel. He is here in the front row. Yeah, so he can give you a matching shirt. Yeah, any more questions? Yeah, there is a question over there. I didn't quite hear it. It was how best way to consume web services. So if you ask me, actually come to PRS session today. It will explain the best way. There are several ways. One way is to go to .NET, declare, actually reference your web service, get the proxy classes. Actually, this is the easiest way. And then just deploy this DLL and call them from the NAV. You will have problems there. The best way would be to actually wrap them into wrapper classes which allow you to call web services. Okay? So it's a much better way because then you do not depend on whoever is on the other side. You actually have your wrapper which exposes an expected set of properties and methods to your consumer, which is CL in this case. So that if something changes on the other end, you don't have to change the CL code. So that would be the best way. But I also have on my blog a demo how to consume web services from pure CL, which essentially constructs the proxy classes, compiles them in memory, loads the assembly, and then allows you to call into it through reflection. I don't recommend that way. It's there just as a pure trick. I don't recommend that because it will have, you will be able to do exactly the same as with just exposed proxy classes. So all of the problems that you would get would still persist. So the best way would be to actually wrap it away in a DLL and then use it as essentially define your own interface to the web service and then call into that interface. Okay, did you get the shirt? Okay. I have more shirts. Lunch? Yeah, I know it's lunch, but this is so interesting. Okay. Oh, there is a question. Yeah. Cool.
Is there a way to use the DLLs you have in the add-ins folder, to use them in reports from RDLC?
Ooh. Can you repeat the question?
If I have a DLL in the add-ins folder, can I use it from an RDLC report? Or do I have to use the GAC?
I think you need to use GAC for that. Technically, you know, I'm not really RDLC guy. I don't know what are the limitations of this language, whatever it's called in RDLC, the scripting language, which can access .NET. Technically, I would say you can load the assembly dynamically and call types in that assembly. However, I never tried that. I wouldn't say it was supported, but maybe you should ask Klaus Lundström about that. Yeah. Why are you running away? There are more shirts. Okay, I know that. I see that. I'm 30 minutes overtime. So, just like this. And then nobody catches. Great. Yeah, thanks again, and enjoy the conference. Yeah.